This is the video for Knapsack Dynamic Programming routine. Here is the routine. It starts out over here on the left and finishes over here on the right. It starts out by filling the numbers at use this one with 0, 100,000 of them. Well, it could have just done 96,000 of them because that's the total number there are. Next, it fills numerically 820 of the values at best value with 0. It starts out with nothing in the solution, and the values for every position in the solution are 0. It sets J to 0, sets R to 0, sets S to 0. We'll see later on they get increased over here on the left. Then it says for W of 1, and over here we have next W, 96, one at a time. There's 96 items. It's going to go around this loop for W for every one of the items. The next thing it does is it sets V to the value of weight at offset J. That's the weight of the jth item, and we know J is 0 here. And we'll see over here, every time it goes around the loop, it increases J by 1. So J is giving us the weight. And then it says multiply that by the value of the weight. And this is weight per ounces. This is the value per ounce. So V is the total value of putting this item into our knapsack. The next thing we do is we move the best value into our back value for 820 of them. The best value we saw up here starts out at all zeros. But in the future, as we go around here for each item, the best values are going to be increased by those in the solution for each one of the ounces starting from 0 to 800 ounces. Next, it sets index K to W, sets U to S, and then adds W to it. S is going to increase over here by 1,000 every time we go to another item. Starts out at 0, then 1,000, 2,000, 3,000. We're going to store information using offset S. Okay, so it sets U to S, adds the W, that's the particular one we're on, so U is going to start at an index, it is an offset, at W or beyond W. Then it says for I of 0, and down here we have next I 820 times, one at a time. I'll tell you it's never going to get there because this statement here, branch of K is greater than 800, is going to happen first, and it's going to go here to CG. But let's see what's in this loop over I. First, it sets T to the back value of I. That is, at this number of ounces before, what was our best value? Then it says if I is equal to 0, we immediately go down here to CD. That means there is no previous one. We're starting at 0. So we can go around the next test. Otherwise, the next test says if T is equal to 0, go to CG. Well, if we can't do that when it says, well, we know there's no previous one, so we can go immediately to CD. Otherwise, we do have to have a back value, because we're going to use that back value to figure out the best solution. Well, once we get past there and know that it either was a back value or there wasn't one, we add to T the value V that we say is the value of this particular item. When we do that adding, then we check to see if it's less than or equal to the back value we already have at this weight of K, Well, then we go to CE. It's no better than the one we found before. However, if it is better than the previous one, it's going to say use this 1 plus U is going to be set equal to W. This use this one is the one that's being offset by S. Each one of the items is going to have this list of values, and in there it's going to put the W if this one is actually the best one. Remember, here it's doing a test saying, is this the best one that can get this particular ounce? At this ounces, this is the best one. Save this. We need to know that when we go backwards through the list to find the answer. Remember, in dynamic programming, we go forward through the small problems, and we get to the end, we go backwards to find out the trail back to the beginning. So we need to use this one. We also set the best value at K to this value. So now when we go around the next time for the next item, it knows here is a solution we found before. You can use it. Then it adds 1 to K. K started at the ounces we were at to start and gets increased by 1 ounce each time. Then it's making all the best solutions it can until here it gets a solution that is greater than 800, but we can only go to 800 ounces. So then we end up over here at CG. We add 1 to our offset of J, which we used over here for that item to get its weight. Then we're going to save the best values and save best at offset R. We're also going to save in best at offset 800 plus R, W, which one we are on. Then we're going to increase R by 1,000. So now that I explained that to you, I'll tell you this has nothing to do with the solution. But what it has to do with is the nice fellow who debugged this program wanted to see what was happening with the best values. So that's the only reason this list called Save Best got entries put in it. It was for debugging this program. Alright, but we do know that S is used and is increased by 1,000 each time. And then we have the next W for 96 one at a time for every one of the items. Well, once it gets done going all around this list the 96 times and knows the answer, well, the first thing it does is subtracts 1,000 from S to get it back to the last one that it did. See, here it added 1,000. Well, we went beyond where we want to be, so we subtracted 1,000 back again. The next thing here, setting A global register to S, is another thing the programmer did. He wanted to see what the last S was, so he set this global register to its value so he could check the program. Then the next thing it does is it adds to that S 800. 800 is the number of ounces we want to use. We want to know how did it get to 800 ounces with the best answer. Alright, so we're setting S to 800. Remember over here we always kept the answer at the offset of the ounces. So we know it's at 800 plus S. Then it says fill answer with 0. All our answer values in the answer list are going to be set to 0 to start. Set NG to 0. NG is going to be increased by 1 every time we find another answer, so we know how many items are in our solution. Then we go to a test here, branch if equal, use this 1 plus S is equal to 0, go to CK. What that is saying is that maybe the very last item isn't in the solution. Therefore, at offset 800, it's got a 0. We got to find the item that is not 0 at that position of 800 ounces. If the last one isn't in the solution, it's not there. So we're going to go around this loop, adding 1,000, subtracting 1,000 from S each time until we find the very one that has a value. When we find it, we're going to set K equal to that value it found. K is how many ounces that thing weighs. Then we're going to subtract our K from S. Remember, we started our S at 800. Now we found an item that is in the solution. What's the number of ounces left? For instance, if we found it at 100 ounces, well, no, they don't go up that high, do they? At 90 ounces, we would be subtracting 90 from the 800 to get 710 ounces. And then we're going to go look for that. We also subtract 1 from K when we want to put it into our answer sub K with a value of 1. Then we increase NG by 1. Then we go around again, and now we're going to try and find the one that has the answer for that many ounces. Well, we keep going around this loop, finding all the answers, that is, all the items in the solution, until S is no longer greater than 0, and then we go home. Now we had the solution. So this is the Knapsack Dynamic Programming routine and how it works. This is the end.